All right, guys, we're going to continue with angles, okay? Now, there's a couple of special cases with inscribed angles. So the first is if the angle is inscribed in a semicircle, meaning it goes through the center, this diameter, this angle B is going to be a right angle when the inscribed angle is formed in the semicircle, okay? All right, couple other things. If a quadrilateral is inscribed in a circle, that's called a cyclic quadrilateral. Not that you really need to know that term, but what you do need to know, which is opposite from normal quadrilaterals, is opposite angles are supplementary. Usually with your rectangle, square, rhombus, parallelogram, opposite angles are usually equal. But in this case, they're supplementary. So x plus y equals 180. Now you're going to see that with this example here, number 1. Okay, check this out. Remember, inscribed angles are half the arc. So if I wanted to find angle 1, let's say, angle 1 is formed by this chord and this chord. And if you look, that's this arc, which is 144. So angle 1 is going to be half of 144, which is going to be 72 degrees. Now, if you look at angle 2 is formed by these two chords, which if you look, that's going to match that arc, which is the 216. So angle 2 is going to be half of 216, which is 108 degrees. And if you look, 72 and 108, that's 180. That's supplementary. So if you have a quadrilateral inscribed in a circle, the opposite angles are 180. Together, they're 180. All right? All right. Check this out. B. All right? You want to find some of these angles, okay? You want to find angle 1, 2, and 3. First off, if you look at this arc forms this inscribed angle. So this arc is twice this angle. This angle is half that arc. So this arc is 2 times 56. This is 112. And then angle 1 is a central angle, so that's equal to the arc. So once I get that arc, it's 112. And then if you look, angle 3 is the rest of the circle. So this arc is going to be 360 minus your 112, which is 248. And then this arc forms this central angle. So angle 3 is 248 degrees. And then lastly, angle 2 is formed by these two chords, which makes this arc, which was that 248. So angle 2 is going to be 248 divided by 2. So 124 degrees. All right? I'll let you try C. All right? If you're stuck on C, not to worry, all right? You're not going to see too many questions like that. All right, next up. All right, and these are easy. Check this out. These are angles formed by chords and tangents. Now, these are just like inscribed angles, okay? They're going to be half of the arc. So, again, a chord goes from 2 points on the circle. So AB is your chord in this problem. And then BC is the tangent because it hits in one spot. If you wanted to, you could extend the tangent, but you don't have to. All right, this angle is half of this arc. Okay, just like the inscribed angles. Think about like inscribed, it's on the circle. If the angle is on the circle, it's going to be half the arc. So angle X is half of this arc. Half of 120, 60 degrees. So angle B is 60. Okay? Sometimes they try to get tricked though, and they don't give you the arc that forms that angle. They'll give you this arc instead. That's question 2. See, instead of giving you this arc, they gave you the other arc. But if you look together, these two arcs go all the way around the circle. So together, they have to be 360. So this arc here is just 360 minus 240, which is 120. And then angle X is just going to be half of that arc. 120 divided by 2, 60 degrees. That's basically this whole lesson here, is just stuff like that. Right? Sometimes, though, they might incorporate algebra. All right? So if you look, this arc is 2y. This arc is 3y. Together, it goes all the way around the circle. So together, those have to be 360 because the circle is 360 degrees. So we're going to add those two up to 360. We're going to divide. And we're going to get 5 into 36 goes 72 degrees, I believe. 72. Right? So this arc is 2 times 72, right? Because it's 2y. That's 144 degrees. This arc is 3 times 72, which is going to be 216 degrees. And when you add them up, that's 360. All right, but the angle we're looking for is half of this arc. So x has to be 216 divided by 2, or 108 degrees. All right? That's as hard as it gets. Everything else is going to be just like number 1 or 2. Right? So let's look at 5. Again, 5 is like 2. Instead of them giving you the arc you needed, they gave you the other arc. But again, together, this arc plus this one is 360. So to get this arc, we're just going to subtract the one we have from 360, which is going to come out to 236. This angle has to be half the arc. So the angle is going to be, angle VRS is going to be 236 divided by 2, which is going to be 118 degrees. All right? That's pretty much everything on this paper, right? We'll do one more with you. All right, number 4. It says find angle BAC, this angle, and arc ADC. All right, ADC is easy, right? That's just 360 minus 130. But remember, this angle, if the angle is on the edge, it's half the arc. So BAC is just half of 130. So angle BAC, 65 degrees. Arc ADC is just going to be 360 minus this arc, because together again, if you look, if you combine those two, it goes all the way around, which is 360 degrees. So 360 minus 130 is 230 degrees. All right? All right, and then the last one on this page, and then you could practice. Number 6, find the missing arc, right? They want to know the major arc. But the minor arc, again, this angle has to be half of this arc. So this arc has got to be twice that angle. It's 100 degrees. And then X is the other arc, so that's just 360 minus 100, 260 degrees. All right, try the rest of these, and we'll talk to you tomorrow.